Hi, my name is Vasily and this is my first AlgoFitness session. Basically what we're going to do in all of these sessions, we're going to lead coding. So right now I'm going to pick one task. It will be easy task, right? Let's start with something not very complex. And then we are going to solve it, try to think about complexity and so on. So idea of these videos is just practice, and let's do it together. Maybe you will learn something, maybe you will help me to understand something. If I make any mistake, you will correct me directly in the comments, right? So let's start. Today we're going to solve problem with title toSum. Given an array of integers, nums, and integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's look at example and try to understand what we're gonna do. So we have an array of nums 2, 7, 11, 15 and target 9. We need to find two elements from array nums that have a sum 9. For example, 2 plus 7 equal 9. So we need to return these two elements, but not elements. We need to return indices from this array. So these two numbers has indices 0 and 1. And here you are, output 0 and 1. Okay. Example 2. We have this array 3, 2, 4, right? And we have a target 6. That means that right now we're going to return index 1 and index 2, right? Here you are. This is our result. 2 plus 4 will be equal 6. I have two solutions of this problem. Of course, we're going to use Swift language, because I'm iOS developer and I like Swift language, but maybe in future I will try to use different languages. Maybe this depends on how you're going to react on the video. And also write please your favorite language. Maybe I will pick one of them for the next video. First solution is not very optimal, because what we're going to do, we are going to find each two pairs in our array, make some calculation, make a sum, and try to compare the result with a target. So it's pretty expensive, but always I suggest to start with something super simple, where you can have a result that is work. I'm going to use example first data, input data, to explain how my code is working. Let's start with line number 4. So we have value I or index I. It will be changed from 0 up to number of elements in array nums. Here we have 2, 7, 11, 15, so just 4 elements. We're looking at example 1 right now. And value I will be equal from 0 up to 3, right? 0, 1, 2, 3, including 3, right? Okay, next line number 5, we have one more property, j or index j. So it will have value from I plus 1 up to the same number of elements in our array nums. Okay, so in the first step, right, in the first step of first loop, we will have j equal 1, right, 2, 3. Let's assume that we have a first iteration of a first loop, so e equal 0, and a first step, first iteration in a second loop, right? So j equal 1. Right now, I mean, I plus 1, that means 1. And here in this line, we're going to make a sum of two elements, right? Element at index 0 and element at index 1. Look at here. So element at index 0 will be 2 and element at index 1 will be 7. When we make a sum of these two numbers, we will get a target, right? So in this line, this is our quitting condition. If it's equal true, right, we return our value. But what will be if, for example, we have another value, right? So like here, we have 3 to 4, right? First element will be 3. Then in the first iteration of second loop, right, we will have number 2, right? We make a sum with them. So 3 plus 2 will be equal 5, not equal 6, right? And looks like we need to go to the next step, to the second step of the loop second, right? So what will be next? Our j will be equal to, right? So we have previously j equal 1, right now it will be equal to. Okay, 3 plus 4. Will it be equal 6? No. That means that we are going to close this loop, right? We finish it, and then we are going to change I. So I right now will be equal 1. We just completed first iteration of the first loop, and then we are going to pick another value. So what will happen? We will pick number 2, right, at the first loop, and then on the second loop we are going to pick number 4. Okay, 2 plus 4 will be equal 6, right? This is our result, and we are going to return index 1 at index 2. Let's talk about complexity, about big O notation. So basically we have time complexity and space complexity. Let's start with the time complexity. How I explain time complexity for myself? We have input data, for example this array, right, 2, 7, 11, 15, and we need to understand how maximum manipulations we need to do with all these elements to get a correct result. Okay, for example, like reading, get element at index 0, this is manipulation, and writing, this is manipulation too. So for right now, just keep it in mind that time complexity means how many reading or writing, or reading and writing of our input data we need to do to get correct result. We are writing some code, right? And we want to count maximum iteration, maximum reading or writing. Can we do it in code? Of course, yes. We just need to count number of steps inside both of the loops. How can we do it? I just modify the code. So I added property count and I increase this count here. So let's try to run the code. Of course, we will have not correct results, but we can understand how many maximum iterations we can do to have a result. For example, here we have 1, 2, 3, 4, 5, 6 iterations, right? So we compare two, so element at index 0, I equals 0, we are going to compare with j1, right? So 0, 1. Then we compare 0 with 2, right? 0, 2, right? Then 0 and 3. 0, 3. For example, it's not our result. Maybe our result will be 26, right? So our target can be 26. So this will be last comparing, right? Last pair. Okay, so next we are going to compare 7, not compare, we are making sum with 7 and 11. Okay, then 7, 15, right? This line. And iteration 6 will be the last. Is it correct? Can we try to understand dependency? For example, right now we can have something like this. So n equal 4, iteration equal 6, right? Iterations. Okay, So what will be if we change input array? Okay, let's try to change our test case. For example, we will have 3 elements. Okay, what will happen? We are going to run it. We have, okay, maximum 3 iterations, right? So when n equal 3, n means number of elements in array, we have iterations equal 3. What will be if we have 5 elements, right? For example, this. Let's execute it. I mean, this is idea how we can manually understand complexity of it. Let's write the result. 10 steps. So n equal 5, iterations 10. Right now we can try to transform our dependencies into our formula, right? So basically, when we talk about loop inside loop, it has this complexity, but we have a little bit different loop. For example, second loop will be changed from 1 to 4, right? We can take this example with 4 elements. Our n will be changed from 0 to 1 to 4, and here our n will be changed from 1 to 4. So probably our formula right now will looks like this, but let's try to use our numbers. If we put n equal 4 to this formula, what we have? We have 4 reduced 3, right? It will be equal 12. Okay. Then 3 produced 2. Okay. And the result will be 6. Then n equal 5. Here we will have here 20. If we compare this number and this number, right? So this is exactly number of iteration we received using our code, using our experiments, right? But here is our math calculation and something wrong with our formula, right? So if we divide all these results on 2, probably we will have our correct number. So here we will have 6, right? Here we will have 3, and here we will have 10, right? So our big O, our space complexity, our time complexity will be this, like accurate formula. And right now we can make this formula a little bit easier, right? So first of all, let's make our calculation. So we will have this result, right? So it will be, and then we can make it simpler. For example, so this part can be simplified to just n square. Why? This formula can be transformed into just n square. We have these most popular complexities, and we try to think where our complexity will be here. So we, as you see, we do not have here a very complex formulas, right? They're pretty simple. And here is the same idea. So we do not need accurate number, we do not need accurate formula. We just need to understand in general how complex it can be, how many iterations with input data we need to do. That's it with time complexity. Right now let's talk about space complexity. Of course, again, I really suggest you to read some articles about it. But in general, when we talk about space complexity, we talk about additional storage for our calculations. For example, right now we have this array 4 elements, but we need to have a different order, right? For example, we want to have here 15, 11, 7, 2, right? To make this work, we need additional storage, we need additional array where we can take these elements, these nums, and put it in another storage, in another array, and sort it. We know that output values will be just 2 numbers. This is what we expect, 2 integers. Even this, we can assume that space complexity 0. Let's try to calculate space complexity for each line. And we can start with line number 8. So here, space complexity will be 0. Again, why? Because we do not have anything related to our input data, right? For this case, of course, we understand that creating loop will require additional memory. But for our space complexity analysis, we just ignore all of these values. Here we do not have any connection with input data, right? So space complexity will be 0. The same here, right? We have nothing connected to input data storage. Here we created 2 values. I mean, we can write that space complexity here will be 2 because we expect it. Again, we can assume that it will be 0, 2. Here, what we can think? Space complexity of this code. So, space complexity of this code will be equal to or it will be 0. Oh, and I forgot something. So when we talked about our time complexity, right, we just try to analyze these 2 loops, loop inside loop. So our formula will be this. This is the first loop, right? This is second loop, right? But what about this part? So what we need to understand, where we touch our input data. We touch it here with these 2 actions, like get value from array. We can go to wiki, article will be this. We can find our basic array, right? And indexing means get value from array using index. Complexity of it will be 1. So looks like here we have complexity 1, right? And here we have complexity 1. Everything else, for example, this plus and this equal can be ignored. Our formula will be changed like this, right? And probably this will be equal 1. So here we have this formula right now, and I think I made this mistake. I mean, previously it should be like this. Yeah, not plus, I'm sorry. So, and right now it will be this. Okay, let's talk about second solution. It is a little bit different because it's based on hash map or dictionary. So right now we have here a dictionary. We create our storage for input data, right? So as you know, our space complexity will be different with this solution. This line means I want to reserve memory for 4 elements, to do not extract it each time when I add new value to the dictionary. And then we have just 1 loop, and you can understand that complexity of it will be on. We have this array, right? 2, 7, 11, 15. We are going to start with index I equal 0. So in this line, what will happen? We are going to check, do we have in our dictionary value 2? Right now we have nothing there, and looks like we are going to this part, to the else condition. We are going to save a value here, but not just a regular value. We are going to save a difference between target and a number 2. Here at dictionary, we are going to save number 7. Let's go to the next step. Right now we know that our dictionary contains just 1 pair, key equal 7 and value equal 0. So in this line, do we have any value in dictionary with key 7. Yes, we already have it. So we just wrote it in a previous step and we return our index. Because we do not need to make any other calculations, we just need to find it. We just need to find number 7 here in dictionary and take this index from it. Let's talk about space first. We have this dictionary and we put values directly on it. It will have the same number of elements as a num. Space complexity will be n. What about time complexity? We can start with this. We have a loop. We know that this will be equal 1, right? Or 1. Here will be the same 1. So we just need to understand what complexity will be with dictionaries when we get and write values. I open here hash table and in average value we have this. So insert will be 1, right? Search will be 1. I mean, search means get value. Get value using key. Hash maps are very efficient hash maps or dictionaries. This is the same. So right now we understood that all of this will be O1, right? Or O0, I mean, because we can ignore all of these values. Looks like time complexity of it will be just n. This is the question. What will be better for you? What will be better? Because here we have less time, but we use more space, right? If we compare with the first solution, as you know, here we use 0 additional space, but we use much more time for calculations. So in different cases, you may use different solutions. That's it for the first AlgoFitness session. Please use comments and tell me about this format. Tell me about how it is going. Is it like too long or it's too slow? Maybe you have some good ideas. And again, I'm not a big expert at algos yet. I am continuously learning something. So if you want to correct me, maybe I did somewhere a mistake and you know it's better, please write your comment. Everyone will win there, right? We are trying to learn it together. Okay, that's it. See you in the next session. Bye.